Okay, now we're going to look at creating a heat map of correlation, okay, pairwise correlation, and we need to drop the um, okay. So we're going to drop your textbook doesn't drop the factor variables. Okay, remember we coded these two as factor variables. If you have factor variable which is like a character variable, you cannot, it's not a numerical variable, and therefore you cannot compute correlation. So we're going to remove that and that. Okay, and then we're going to create a heat map where highly correlated, either on the positive side or the negative side, will have a brighter background color and a lighter background color if they are not correlated. So it will be closer to zero on either the negative or the positive side. So that's what we need to achieve. Okay, so first we need a library for that to generate, to reshape the correlation values um, into a plottable series of data, and the library that we need is called reshape2. Reshape2. So let's get that library going. Okay, now we will remove the non-numeric variables. So here we're going to do data for plot is housing df. So we're going to use subset. Okay, so that way we can use the names. If you can either do this with the column number. So if you just did housing.df square bracket and comma for all the rows, and then you can put a list minus c and then the column number of chast and column number of catmet v, that will work. But we want to use the column name, so we need to use subset of what? Subset of the housing df. All right, and then we say we want to select columns. Okay, so select equal to what columns you want to select? Well, we want to give a minus c, which means don't select these columns. So we have chas and catmed. All right, so let's run that, and you see data for plot, the two variables are gone, so you have 12 variables and 500 and 6 observations. Okay, now we can run the command for correlation is just COR. So COR is the base R, the statistical function. So we then specify the data for plot, and if you run that, then you'll get all the pairwise correlations. Okay, so we want to capture that. Okay, so they say core.mat. Okay, so we have core.mat, which is all the correlations. Okay, all right, so now is when we have to string this up. Okay, we need to do a reshape, and this is called melt. Okay, so melted core mat. So we do melt. Okay, core.mat. What this will do is it will take each pair of the two variables. Okay, put one variable in column 1 the second variable in column 2 and the corresponding correlation in column 3. So that's what this melt will do. Okay, so let's look at melted core.dat. So variable 1, variable 2, and then the value. Value is your correlation. Okay, so I'm not going to change the column names. If you want, we can do that. But let's go ahead and plot this. So ggplot. Okay, data equal to melted core.mat. Okay, and then mapping equal to AES. Okay, so we want, okay, so here let's look at the heat map. So we have the one variable as x-axis, so var1 as x-axis and var2 as y-axis. All right, and then fill is going to be our value. So it's going to be filled with the value column, which is the correlation, right? So AES equal to var1. So make sure that, okay, so the first letter is uppercase and then AR1. So which is what I have. Do I have an uppercase there? Yeah, okay. And then y equal to var2, and then fill equal to, okay, the value that we want to fill, that column is called value. Okay, so here, so that's value. So we do value. All right. And then we need to tell ggplot what kind of filling we want. Okay. So once this is done, you have to do geom text. Okay. And AES, okay, x equal to var1, y equal to var2, and label equal to value. Okay. So this fill will give you how dark or bright, and this label will display the actual value of the correlation. So here it is, and it looks messy, isn't it? One thing is that it doesn't have color yet, so we have to specify that, and more than that, the correlations all have like 6 or 7 decimal places and they're running into one another. So what we have to do now is to round the correlation. So let's go ahead and round it right here. Round to 2 decimal places. Okay, so now we have to run both of these commands again. See, now they're all in 2 decimal places. Okay, so now if you run that, then that looks good. Okay, now let's specify what the fill color is going to be, and that is scale fill gradient. Scale fill gradient 2. Okay, so that's going to specify the color gradient how you want it, what color you want for the lowest value, what color you want for the highest value. Okay, but here what we want is the same color for the two extremes, -1 and +1, and then a color for the middle. So what we can do here is you specify the limits. Okay, what are the limits? Limits equal to, so you give that as a list, -1 and 1. All right, so the values go from -1 to +1, and then we can say low equal to, so what color you want for low equal to, say red, huh? And then high equal to red as well. Okay, so now we need a plus here, so the next line of code will get executed together. Then we have to specify how these colors should be used, and that is geom tile. So geom tile is what gonna give you the chart. Okay, so here we have red for -1 to +1, and then kind of white here. Now if you want border in between, so we can give a color for tile, so color green will give you a border for each cell, and you can specify say low, high, and the midpoint. So if you say mid equal to I don't know, say blue, then as the values come closer to 0 from either side, from -1 side or +1 side, so it will become bluer and bluer, less red and more blue. Or if you want to use here, they have not used the same color scheme anyway, so let's not worry about that. So usually here midpoint, the default is white for